Hi there, and welcome to Mr. Morgan's Math Help. This is Algebra 1, Unit 4 on equations and inequalities, Lesson 1 called Cafeteria Actions and Reactions. And so the learning focus today is really solving multi-step linear equations and using what are called inverse operations. And this is something you have done in prior courses, probably back starting in 7th or 8th grade at the latest. And so that's what we're going to continue doing today. So our questions today that we're looking at is, how does connecting the operations in an equation to an action in a story help me to develop and justify my solution process for solving the equation? We're talking about operations for solving equations there. And then how does the structure of an equation give me clues about how to solve it? So when we look at different equations today, we're going to look at how things are set up to see what might be the best way to go about solving something. So you did some activities. There was a story in class. They read through about counting kids and different ways of doing it and different methods about kind of putting everything together. This was the third thing in that series of things from your lesson today. What said here are 3 different equations that could be written based on a particular sequence of notes. Examine each equation, then list the order of the 5 notes that is represented by each equation. Find the solution for each equation. So really what we're talking about here is, here you have 3 different ways of solving something, and the way it's set up, there'll be a different way of approaching it. So in this first one, for example, if I'm going to solve a problem like this, what I'm going to do first is I'm going to multiply both sides by 3 in order to get this 3 to leave the denominator. In doing that, this reduces down, and I'm left with 2 times x plus 4 equals 12 times 3, which is 36. After that, I want to get the x plus 4 by itself, so I'll divide both sides by 2. Again, that reduces down to 1 and 1. And I'm left with x plus 4 equals 18. After that, I subtract both sides by 4 and discover that x in this first one equals 14. Now, if I do this one over here, similar numbers, we have 2 times x divided by 4, or x over 3 plus 4 equals 12. So similar things, but let's just see what this works out to be. And you can see how we're playing with different parentheses here to kind of change the structure of the problem. So the first thing I would do here is divide both sides by 2 in order to eliminate the 2 next to the parentheses. So now I have x over 3 plus 4 equals 12 divided by 2, which is 6. The next thing I would do is I'd subtract 4 from both sides so that I have x over 3 equals 6 minus 4 is 2. I'm going to just draw this up here real quick. So I have x over 3 equals 2. Now to get the x by itself, I'll multiply both sides by 3. So that reduces, so that x equals 2 times 3, 6. So I have a very different answer there because of how the problem is structured. And for this last one, I'll multiply both sides by 3. And again, we can see here the difference is I don't have a parentheses around like that one like I did over here. So I end up with 2x plus 4 equals 36. I subtract 4 from both sides, and I'm left with 2x equals 32. Divide both sides by 2, and x equals 16. So in each of these problems, I end up with a very different solution. Here, x is equal to 14. Here, x is equal to 6. And here, x is equal to 16. So depending upon the order in which I work to solve this equation, I end up with a different solution. Now, a lot of the order here has to deal with where the parentheses are at, like for this one here, and this one has no parentheses. Or, for example, where the 3 is at. Here, the 3 is below that part of the equation, and here the 3 is included inside the x. So that difference there, those small differences make a difference in the ultimate outcome. So it's really important when we're solving equations to be careful about the order of operations that we use. You might have done this before, where maybe you did the old PEMDAS thing, right? Where the idea is you do parentheses and exponents kind of first, then multiplication and division, and then addition and subtraction, always working from left to right in your equation if there's kind of a tie, if both things are happening. So that's something you maybe learned a long time ago and hopefully can apply to this activity today. So in this lesson, really, we learned how to solve multi-step equations in the context of using operations to represent actions in a story. We observed how to undo the actions of the story. We developed a strategy for solving the equation by using inverse operations. So that just means, like, if I saw something that said x plus 2 equals 10. Undoing means I'm going to take that out by doing the opposite or the inverse operation in order to get the x by itself, right? That's the undo or inverse part, right? Instead of adding 2, I'm subtracting 2. The order in which inverse operations are applied when solving an equation matters, so order matters, and we learn how to pay attention to the structure for clues for how to solve things. So today you're going to work on your lesson activities and then hopefully press pause here, get those done, then come back and see how you did, and I will go through a few of the solutions. Okay, here we go. Let's take a look at homework today. So homework today, first of all, we had several questions where it says to graph the equations on the coordinate grid and determine if the given point is a solution to the equation. Now the given point, I just chopped it off an accident here, is 1, 3. We'll come back to that in just a second. So there's a couple ways of graphing this here. You could make a t-chart, right? We could say x and y, and we could plug in a value for -1, 0, and 1, and see what happens. So if we have 5 times -1 minus 2, we end up with -5 minus 2 is a -7. If x is 0, we have 5 times 0 minus 2, end up at -2. And if x is 1, we have 5 times 1 minus 2, or simply 3. So it's become 3 points that I can use. Now I'll use the grid they gave me here, and I can plot those out. -1 is at 1, 2, 3, 4, 5, 6, 7, -7. 0 is at -2, and 1 is at 1, 2, 3. So that becomes my first equation there. And now in this case, because of how it's set up, they want to know, is this point on the line? Well, because of how I did my t-chart, I know I have that point. Whoops, that was not what I wanted to do. And so we would say definitely that point is on the line. Yes, it is. Another way of solving this one, and we'll show you in a second here, is you might simply start with the y-intercept, and you put that point at -2, and then look at your slope, which is 5. So 5 is really 5 over 1. So this becomes how much I go up or down, and this becomes how much I go to the right. So I would go up 5, 1, 2, 3, 4, 5, and over 1, and plot that point. 1, 2, 3, 4, 5, and plot that point. So same idea, and you'd be able to then also say once again that yes, that point is on that line. Okay? Let's look at the next one. So number 2. Here we have y equals -1/2 plus 8. So what I'm going to start off on this one here, I'm going to go ahead and draw my graph like so. And I want to see if this point is on the line. I'm going to look at my y-intercept as +8. So 1, 2, 3, 4, 5, 6, 7, 8. So it's right there. And then we see our slope is -1 over 2, which means we're going to go down 1 and over 2 to this point, down 1 over 2 to this point, and so on. So my graph would look like this. And the question is this point 0, 7 on that line? Well, here's the point 0, 7 is right there. And we can tell that no, it is not on that line. Another way of checking it out is I could, -1/2, I could plug the x value in for x and see if I end up with the y value. So -1/2 times 0 is 0, plus 8 is 8, and we see that that does not match. And as a result, we still keep it with the no, it doesn't quite work. Okay. All right, so the next one here, you're going to graph that out. Again, a couple ways. Like we've said, you could do your x, y. You could look at your y-intercept and your slope. Your slope here happens to be what? -1 over 1. Why? Because there's a 1 right in front of that x there. So you could plug in some values, and then if you wanted to know if that point is on the line, what do? We plug it in. We say, here's my equation, -x plus 4. And that's going to equal our y value, right? That's what this says right here. So if I put the 2 right there, I would say -2 plus 4, which becomes a +2, equals y. Does that equal that number right there? Yes, it does. So we would say, indeed, yes, this point is on that line, but you need to graph it out yourself there, okay? Number 4, same kind of idea. You're going to graph that out. It should be simple enough with a y-intercept and a simple slope of 1, and then use that to see if that's going to work for you there. And number 5, same idea. Now we have a slope of 5 over 2, which again means what? If I'm starting here, I'm going to go up 5, 1, 2, 3, 4, 5, and over 2. And I can go down 5, 1, 2, 3, 4, 5, and over 2. So I should have a line that looks something like that, but now I need to actually put it onto the coordinate plane there, which you could do by figuring out where your y-intercept is at, which is at -7. So do that there, and then of course you could plug it in and see what happens for number 5, as well as for number 6. Let me do one more, just to kind of wrap this up for you guys here. So here we have our line. Here we have our coordinate grid. We do not have a y-intercept, so our y-intercept is going to be at 0, basically. Okay, so that's our first point is at 0, 0. If I did x and y and put some points in, -1, 0, 1, we know it's 0 because if I put x times 0, I get 0. If I do -1, I would have -4/3 times a -1, and that equals a +4/3, or 1 1/3. If I did a +1, I end up with a regular 4/3, or I end up with a -4/3, or -1 1/3. So at -1, I'm at 1 and a little bit, and at +1, I'm at -1 and a little bit. Oops, sorry, here. Now, those aren't actual points to look at, so it's hard to see. I could also notice that I'm doing down 4 over 3, right? And I could go 1, 2, 3, 4, and over 1, 2, 3. That becomes a point on the square grids here. I could also go up 4, 1, 2, 3, 4, and over 1, 2, 3, and then connect the dots, which should go through my other points anyways. So now the question is this on that line? Now we can look right away and say, well, that point is 2, 5, 1, 2, and -5. 1, 2, 3, 4, 5. That point is right here. So is that point on the line? We would say, no, it's not. It's definitely not on the line. The other way of trying to figure that out is to say, well, we know that y equals -4/3 x. So if I plug the x value in, do I get the y value? -4/3 times 2 becomes a -8 over 3, or a -2 2/3. Either way, that does not equal 5, so we would -5, so we would definitely still say no for number 6. Now this next set of questions here, there's 4 of them. They want you to look at the equations provided and identify the first operation that would be performed on the variable, and also identify the last operation performed on the variable. Then determine the first step that would take place when solving and the last that would take place in solving. If needed, solve and check your solution. Okay, so when I looked at the answer key, for example, for number 7, I wasn't sure actually what they were wanting me to do. It was just a little odd. So their way of doing it just didn't make a ton of sense to me, but that's okay. Let's take a look at number 8 instead as a sample. I'll let you go back and do that one on your own, just because I don't want to mess you up with what I say is the answer compared to maybe what your teacher might say. So in terms of the n, the first thing I'm going to do to the n, in this case here, so what happens here to here, the n is going to be multiplied, let me write out, multiplied by 4. That's the first thing that would happen to the n. Whatever the n value is, I multiply it by 4. That's the first step in my order of operations. The next thing after I've done that would be then, whatever that answer is, I would subtract 12 from whatever that one was. So I begin by doing 4 times n, and then I subtract 12. In terms of solving, what I would do first actually is I would recommend, and this would be what you can do, I recommend it's what you have to do, I would add 12 to both sides first. And that gives you 4n equals 40. And then my next step would be divide both sides by 4. And then I've solved it. And divide by 4. So it's really kind of two things you're asking you to do. It's kind of like if you're working with just the n, what do you do with it? And then how do you solve it? So that's how this little square grid thing is set up. This one here, just the way the answer key worked, just didn't quite make sense with what you were doing, but you get the idea. Let's take a look at another one here. Okay, if I am solving number 9, let's look at number 9. Okay, the first thing that happens to the t, if I'm looking at t value, is t is going to be, first of all, multiplied by 2. Right, that's the first thing that would happen to the t. It'd be multiplied by 2. After it's multiplied by 2, I'd have a number here on the top of the bar, of the divisor. So I'd probably add that next and get those together. And then after that's together, the last thing I would be doing would be dividing by the 3. That's what's happening with the t. Now in terms of solving though, what I would say first of all with solving is I would multiply both sides by 3 in order to reduce that down to 1 and 1. And so now you have 2t plus 8 equals 8 times 3, which is 24. So the first step is multiply by 3. Now as I continue to solve this, 8 minus 8 becomes nothing. So 2t equals 24 minus 18, or 24 minus 8, which is going to be 16. And then I'm going to divide both sides by 2, so t equals 8. So my last step is actually divide by 2 in order to get t equals 8. So just an interesting way of looking at it. I'm not sure exactly what the purpose of this part is, but that's okay, as long as you can kind of do it. So you can do number 10 on your own as well. For the next ones, 11, 12, 13, 14, 15, 16, they want you to solve each equation. So I'm going to go ahead and just solve some odd ones for you real quick. All right, so working these out, we're going to add 6 to both sides. So 42 equals 3x. Divide both sides by 3. And so x is equal to 14. Over here, I'm going to multiply both sides by 5 in order to get this away. Then you're left with 4 times b minus 2 equals 40. I'll divide both sides by 4 in order to get that apart. So b minus 2 equals 40 divided by 4, which is 10. I'll add 2 to both sides, so that b equals 12. And this last one here, I'm going to start by subtracting 2. So then I have 4 times x minus 5 equals 16. I'll divide both sides by 4 to get the part in the parentheses by itself. 16 divided by 16 divided by 4 is 4. And then I'm going to add 5 to both sides so that x equals 4 plus 5 is 9. Okay, so we have a 14 for 11, we have a 12 for 13, and we have a 9 for 15. The last couple here just say indicate whether the given value is a solution to the corresponding equation. A little bit like we did with the graph one earlier, except now there's no graphing. You're just going to take this value and plug it into that space and decide yes or no, does it make this true, right? It has to equal that. So if we take 4, we multiply it by -3, and we add 3, the question is, do we get -9? That's our goal. That's what we're aiming for. So 4 times -3 is -12 plus 3. -12 plus 3 is -9. And sure enough, that equals that. So we would say, yes, that does work out just fine. All right, same idea for number 18. You're going to take the 4/3 and you're going to drop it right there and then multiply that out and then work with some fractions to see yes or no, is that value a solution? Number 19, same idea. Take the 2, put it right in there, multiply that out, and then see, is that a solution once you work that out, yes or no? I'll do one final one here. I'll work on number 20 because it just has lots of parentheses. So let's write this out. We're going to put -5 in there. So we have 2 times 5 minus, and I'm going to put this like this, 2 times negative 5, like that, equals 20 minus 2 times negative 5 minus 1. So a few things kind of crazy going on here. First of all, I see that I have this multiplication piece in the middle, and I also have this little subtraction piece in the middle there. So on my next thing, let's go ahead and do this here. I'm going to say it's 2 times 5 minus, well, 2 times negative 5 is a negative 10. And that's equal to 20 minus 2 times whatever this is. Minus 5 minus 1 is minus 6. Now my next thing I'm going to take a look at is I see another thing in parentheses, so I'm going to work on that there. And then I can work on this right here while I'm just, since I have them kind of separated anyways, right? So on this side, on the left side, we'll have 2 times 5 minus a minus 10. When I subtract the negative, I'm adding, so that becomes 15. And that's equal to 20 times negative 2 times a negative 6 is a positive 12. At this point now, I'm going to go ahead and multiply those together and add those together. And in doing so, 2 times 15 is 30, and 20 plus 12 is 32. And we would say these are no longer equal. These are definitely not equal. This is a no. Negative 5 does not work. It's not a solution for that problem set there. Okay? All right. And that really is it for the day. Hope that helps you out with your homework, and hope to see you again soon. Thanks.